Hello, everybody, and welcome to the Week 3 live session for critical thinking. So this is a special recording because we were having technical issues last night with the recording, so everything seems to be a little bit better today, so I'm going to attempt to provide you with a summary. So the good news is this is going to be brief. We're not going to do a full hour. And the other good news is we are going to focus on helping you through the assignment. And that's another reason why it's going to be brief, because I want everybody to watch this recording. So let's start out with looking at our checklist, and then we're going to go right into the assignment. And I'm going to explain in greater detail truth tables. All right, so let's take a look at this week's checklist. Let me make sure my screen is shared here. Sorry about that. 1 moment. All right, so here we are with this week's checklist. We have the reading from Chapter 3, Reality Assumptions. We also have do the online presentation. The online presentation, extremely important. Oh, sorry about that. There we go. The online presentation, extremely important this week. Please definitely view the presentation in full, because what I'm going to be explaining builds off of what you've learned there and kind of clarifies and explains in a little bit more detail and related directly to your assignment. So please do watch the presentation and take notes. So it's very important you take notes and you watch the presentation, you read it. You can also play the audio to go along with it, and do as many times until you really kind of feel you have your mind wrapped around it a little bit, and then go ahead and watch this presentation on our assignment. We have the discussion, the assignment, and the pre-assessment quiz 3. So you do have a quiz 3 this week. And we are still not doing PAL yet in this particular section of the course, so you do not have to worry about PAL for the next 2 weeks. We may begin that on week 6. I will let you, or I'm sorry, actually week 5, I will let you know. Okay, so let's take a look at our assignment. Assignment 3.1 is based off of truth tables. And basically what we're trying to do here is to get you to make 2 truth tables, one for each of these arguments in step 1. All right, so as you've learned with your presentation, there is a really neat way to prove that an argument is invalid. Why would you want to prove that an argument is invalid? Because if you can come up with an instance where the argument does not logically work, then you have destroyed the argument and proven that it is invalid. By saying it's invalid, that means there's an instance, at least one instance in the world, where if all of the premises are true, the conclusion is not true. And that means that's an invalid argument. So again, the definition of invalidity is all of the premises are true and the conclusion is false. So that's why we build the truth table. It's really just to prove that, hey, even there is an instance where all of your premises are correct, but your conclusion just doesn't follow. We can't prove it. So let's take a look at our deductive argument form. So you're going to need 2 handouts for this assignment. Number 1 is this handout here in step 3. And then the second one is under document sharing over here on top in the course. And that's actually the assignment I want you to download, complete it, and turn it back into me into the Dropbox. So we'll explain that in a little while, and I will go through how to do this assignment using the truth table. But let's take a look quickly at your handout, which discusses deductive argument forms. So you will be clicking right here on step 3, access the handout, which I have done, so go ahead and bring that up. Now, we are going to take a look at, there we go, the different types of truth tables. Okay, so number one, first we represent each variable in our argument. So what's a variable? Tim goes to the store. Tim, in this case, is a variable. So for Tim, we could put T. So T goes to the store. Or we could say that Tim is a boy. How about that? That's even easier. So all T are B, right? All Tims are boys. So that's basically a way of symbolizing our argument. Why do we want to do this? Why do we want to make this down into a mathematical looking formula? Because this way we can take our judgment out of it. So if I was to say all boys are smart, Tim is a boy, therefore Tim is smart. That argument logically works, and we can prove that with the truth table. However, the value of one of the premises, all boys are smart, could be debated. So then it makes it more confusing to say, well, how can you say that all boys are smart when I know some boys that are not smart, right? So you're basically arguing the truth or falseness of the statement, right? But what we want to do is look at, does the argument form actually work? So there are valid argument forms and there are invalid argument forms. So let's take a look at some of these and put these into symbols. So the first one is called the tilde or tilde. And this represents that we decided to change there. Okay, so this means that the variable is it's a no. So the tilde means no. So if we have P and P is true, right? No P would be false. So let's say I'm talking about I have a piano. If I have a piano, right, and that statement is true, then no piano would mean that that statement is false. So I have no P, that means that's false. Conversely, if I have P, right, if I have no P, there's no piano, that's false. The opposite of that is true. So that's called negation. The second type that we write in valid form is called the conjunction. So this means and. Now, let's look at table number 2 here. Table 2 says if P is true, so that means I have a P, and Q is true, that means I have Q, then both P and Q must be true. The only way that this column is going to have a T is if I have both P and Q. So for me to say, this is called a conjunctive statement. So for me to have P and Q, I must see a true for both P and Q over here underneath. So that's, I'm saying I do have P, I do have Q, so therefore I have P and Q, right? If I only have P, but I don't have Q, then I don't have P and Q together. See how that works? If I don't have P, but I do have Q, I still do not have P and Q. And if I don't have P or Q, I still do not have P or Q. So the only way this could be true is if both P and Q are in existence. Right, the next kind is called a wedge or a disjunction, and it's basically the way of saying the word or, O-R. So here I have P or Q. So in my first 2 columns, I am creating all of the different possible combinations that could exist with P and Q. I could either have both, have one or the other, or I could have neither. So if I have both, then to say I have either P or Q would be correct. In order for a T to be in this column, we're going to need to see either a P here or a Q here. As long as I have a true for a P or a Q, then I can put a true in my last column. So in this case, I have a P and I have a Q. So do I have a P or a Q? I sure do. I have both. So that statement's true. True for P and false for Q will also be a true for P or Q. On the next line, I don't have a P, but I do have a Q, so I still have either P or Q. So that's true. The only time that that statement is not true is if I don't have a P or a Q. Then do I have a P or a Q? That statement is false. Now the next one is horseshoe, or we call this if-then. And also you very often see an arrow that points to the right. That would say, that means it's an if-then statement. So if you see the horseshoe or the arrow, you want to read it as if P, then Q. And that's exactly what this says. So when we're doing a conditional, only in the case we can only call it false if we can show an instance where P exists, but Q does not. Because if P leads to Q, right, then both would have to exist. So in this case, we've got a true for P and a true for Q. Therefore, we can say that statement is true. But here's the one where it's not true. So if I have a P but I don't have a Q, then obviously P cannot lead to Q because here's P and there's no Q. So that case is false for the conditional, or the horseshoe, or the arrow. The other two at the bottom, we don't know whether P, well, we know P is false, so there's no way we can tell if Q is in existence based on P. So we would have to say true because we cannot invalidate, we cannot say that that's false because we don't know. So if the only case on a conditional is where true leads to a false, and that would be a false. Now we are building here so that we can actually do a truth table based on P. So the last one to understand is called a triple ball. We're not actually using that for this assignment. But this means basically the two are equal. So only if you have a true and a true, or a false and a false, could you prove that these two are equal. If you have a true and a false in either direction, then you have proven that this statement cannot be true. Right? P cannot equal basically Q if you have a true for Q and a false for P. So if you have a true and a false in any direction, anyway, here's a true and a false and a true. Both cases, P cannot equal Q because you have one and not the other. All right, so those are our basic building blocks for your truth tables. Now, what we want to do for this assignment is we want to create a truth table. The truth table will consist of the variables. Right? So we have, in this case, we have a P and a Q variable. So I have one column for each of those. And then I have another column for each of the statements in my argument. Okay. So what we're looking for is to see if there's any way this argument can be invalid. So I want you to concentrate here on the last grid here when we look at this. If we say that P leads to Q, that's what we're saying here, and there is a P, therefore Q. This is called a modus-ponens argument. So we have, first of all, to indicate all of the different possible combinations of P and Q. Right? If you have two variables, you're going to have 4 lines. I'm not going to go into the equation on how many lines you get, but let's just know that for 2 variables, we're going to need 4 rows underneath the header row. And then we're going to come up with all different possible combinations of P and Q. So I can either have both true for P and Q. I can have a true for P and a false for Q, or a false for P and a true for Q, or I can have both false. So these are all of the different combinations. And the trick to doing that is for the first variable, you enter in P, T, and F, F. And then on the second variable, you alternate P and F. So P, F, P, F. And that gives you all possible combinations of the variable. Next, we list our first statement. So our statement is P leads to Q, or P indicates Q, or if P, then Q. All the way to the top. The conditional statement. So, how do we know? What do we put in here in our truth table underneath our conditional statement? Remember, we can only say that's false if we have an instance where P does not lead to Q. Right? So there's no way that can be true, because here's a P and no Q. Right? So here we have P and no Q, so P leading to Q must be false. For all the other instances, we would say it is true. Remember that if we have a false premise 1, there's no way we can say that that's false based on the information we have. So it may be true. The only way we can say definitely false is the second one. All right. Then we have the next statement in our argument. So if P, then Q. P, therefore Q. So if you do your homework, you will get a good grade. You did your homework, so you got a good grade. Right? That's the argument we're talking about here. Right? P being doing your homework, Q being get a good grade. So let's say that we have P. So we're going to enter in, if we have a true, and remember, a P column is not going to change, and neither is a Q column. So we already made the column. So basically, if you wanted to, you could just copy these over underneath, but they have to be exactly the same. So here we have P, and then you see the TTFF underneath that, right? Same over here, TTFF. So those don't change. So if you've got a P column, it's not going to change. So here is line 2 of our argument, or second premise. P exists. So in this case, we'll say we did our homework. Therefore, we got a good grade. And this is Q. And these are, again, the columns from Q. So what we are looking for in an invalid argument is any case where there's the 2 premises. Right? So these columns right here are those 2 premises. If I have any cases where all of the premises are true, but the conclusion is false, this is an invalid argument. Okay? But here I do not have any cases where that actually exists. I only have one case where both premises are true, and I have the conclusion being true. So in this case, if we did not, we can call this a valid argument. There are different types of valid arguments in your textbook and in your presentations this week. It goes over the different types of typical valid arguments. And I really, really urge you to study these, because when you get good at identifying these in people's conversations and writing, that's where you become a master arguer. Okay. And you can really point out invalidity in other people's arguments. That's a lot of what we're going to be doing in this course. We're going to be talking about fallacies pretty soon. That's a pretty neat way of also blowing apart someone's argument. All right, back to the topic. Our assignment 3.1. So now is the really, really good news for you. You have shared with me for the last 15 minutes, so now I will reward you with a gift. So in your assignment, in your course, I should say, I should go up to Doc Sharing, and I have a handout for you to complete and turn back to me for this homework. Okay, so I have given you a worksheet, and I'm going to go over that worksheet with you right now and do it with you, but you're going to fill it out and answer the questions and turn it in for your homework. So really, we're really working through the concepts of truth tables here, and I want you to be able to apply it yourself. So let's take a look at this handout. It's called Assignment 3.1 Worksheet. And again, it's available in Doc Sharing. You will need to download that, save it, and then open it. Make sure you can edit it. You may need to change from read-only to editing or save as or something like that to be able to do that. All right, so looking at our worksheet, we have our assignment. So here's the two arguments to argument number 1 from our assignment. You can't have any cake today, therefore you can't have any punch either, because if you have cake, then you have punch. So how do we do this? First of all, where's the conclusion? So take a look at this. I'm going to give you a moment. Take a look at this. What is the conclusion of this argument? Arguments don't always follow, here's my first premise, here's my second premise, and now I will give you my conclusion. They can come in any order, so you have to be able to seek them out. So what's the conclusion? The conclusion is actually what the argument began with. You can't have any cake today. Okay. So first of all, let's turn our variables into letters to make it easy to see in logical format. So we're going to say C equals cake and P equals punch. Okay. Now, so to do our truth table, now we have to start filling in the values. So how do we do it for the first variable? Remember, to get all possible combinations of true and false, we're going to go true, true, false, false. And then we are going to go, and then we're going to go true, false, true, false. So we alternate on the second. Okay. So now we have all possible combinations of true and false. We're almost there. We're halfway through problem number 1 already. See how easy that is? Now, we're simply going to find when premise number 1 is true or false. So premise number 1 is C leads to P. How do we know that they said that? Well, here it is. If you have cake, then you have punch. So that's premise number 1. If you have cake, then you have punch. Okay? And that's symbolized by C leads to P. So we use the horseshoe symbol. C, horseshoe, P. Okay? So C indicates P. So if C indicates P, there's only one way that we can prove that that's invalid. You remember which one it is? It is if we have C and no P, then obviously C doesn't lead to P, and that's going to be a false. So we're going to put that here. So if you have P and no, if you have C and no P, then C leading to P must be false. The other instances, we have a true and a true, so that's going to be a true. We have a beginning with a false, so there's no way we can say that that's false. So we have one false. Okay. Now negation, remember negation's pretty easy. It's going to be the opposite of our other columns. So now, so this is the negation symbol, no C. Okay? So if I have no C, it must be the opposite of my original C column. Okay? So this column here for no C or tilde C has to be exactly opposite of my first column for C. So we're going to, instead of TTFF, we're going to put FFTT. Oops, not that. FFT. Now we do the same thing with the negative of P, or the negation of P. And that's going to be false, true, false, true. False, true. And we need to make sure that it's the opposite of the P column. So, false, true, false. Make sure that the negative or the negation of P is the opposite of the P column. The column is the opposite of. All right, so we have truth table for problem number 1 done. That was pretty easy, right? You're going to have to do it yourself because I'm not giving you the file completed. So you got to go through, and if you have to follow along with this, that's okay. You are learning. And then after we've done the truth table, we need to answer these questions. So in your document, I want to see this truth table completed correctly, and then underneath these bullet points, I want you to answer these questions. Is the argument valid or invalid? If valid, name the argument used. How do you know? So this particular one, how do we know if it's invalid? It is invalid if we have any instances where all of the premises are true, but the conclusion is false. Right? Remember that from our definition of invalidity? So if I was to see something like this, I'd be in trouble because I have an invalid argument. In this case, I have shown where I have an instance where premise number 1 is true, premise number 2 is true, but the conclusion is false. So we are going to say this argument is invalid. If valid, name the argument used, so that doesn't apply to this one. How do you know that it's invalid? Right? Now I want you to explain in words that only lines in a truth table that lead. So if you have let's start over here. If you have true premises and a false conclusion, you have invalidity. So that's basically what you need to tell me. If I see a line in my truth table where all my premises are true and my conclusion is false, I have proven this argument invalid. And that's how you know. You have answered successfully the first question of the assignment. Let's go on to number 2. Number 2, Gina will study with George. Now here we have what we call a disjunctive. So this is called an or statement. So we have to write in our conclusion, our variables, and state in symbolic form what our premises are and what our conclusion is. So first of all, we're going to do all of the possible combinations of true and false of J and B. J equals George, B equals Gina. So we would do, what do we put here? We put true, true, false, false, remember? So true, true, false, false on the first column. And then what are we going to put in on the second column? We are going to put true, false with an alternate. True, false, true. And that gives us all the possible combinations of our variables. True, false, true. Then we're going to look at premise number 1. So this is called a disjunctive. So it says J or B. So I look back over here at my first column. If I have a J or a B, we're going to put a true. If I have no J or B, then we're going to put false. So we can see right away, pretty quickly, that for the first row I have J and B, so that's true. Second row I have J, that's true. Third row I have B, that's true. Fourth row, not so much. Fourth row, I don't have a J or a B. So that's basically B. All right, let's look at premise number 2. Premise number 2 is no B. So notice how we put this statement, this argument, into easy format. Premise number 1, there is a choice between George and Begonia. Okay. Premise number 2, no Begonia. Begonia is not able to study this. So we symbolize that easily by saying, no, no Begonia. So in no B, we are going to copy the B column, only using the exact opposite. Okay? So remember, we don't change the values here. So not B, if I have B is true, then not B is going to be false. If I have B is false, then not B is going to be true. Here I have B is true, so not B is false. So basically what we've done is FP instead of EFPF. Now conclusion, J, right? We already have a J column, don't we? So we know in this case, keep the same format going so everything logically ties together. Copy that column. Okay. Now, do we have any instances where we have true premises? All the premises are true, but the conclusion is false. No, we do not have any instance of that. So we know that this argument is valid. So for the questions underneath the table, you have completed the table, all done. Is the argument valid or invalid? For this one, we've got a valid argument. If valid, meaning the argument used. So that's something I'm not going to give you the answer to because it is in your presentation. So I want you to go look at if I have a disjunctive statement and I prove that I don't have one of the variables, then the conclusion is that I do have the other variable. Do I have to either have J or B? If I don't have B, then I must have J. And that is a very common format of argument. And I want you to come up with that in your conclusion when you're writing about this. So you're going to say, this follows a valid argument form. You're going to give me that form. Look through your presentation. How do you know? Because you do not have any instances where you have a true premises but a false conclusion. And that's how you know your argument is valid. All right. So again, for your assignment 3.1, you're going to want to download this handout. Again, it's available in the doc sharing area of the course up here, and it's called Assignment 3.1 Worksheet. So do please download that, complete it, and send it back to me so it's got the blank truth tables, and then you're going to need to write about it. So if you're missing any one of those pieces, you'll be losing some points there. So make sure you're thorough in your assignment. Now that we have thoroughly gone through Assignment 3.1, Discussion 3.1, it's just basically reflecting upon that. So we are answering the questions. If argument forms are always valid or invalid, what's the benefit in being able to recognize them in speech and writing? Okay. So why would you want to be able to say the logic you are using is absolutely invalid. It is a proven invalid format. So you have no claim. Why would you want to do that? What's the value in that? So basically, we're just talking about where you can apply this principle in life. Maybe it's in your career. Maybe it's in analyzing information that comes at you. Right? How many newspaper articles do you read, or how many news articles do you listen to on the news, radio, or television? And you're hearing arguments all of the time. And if you're not a little bit savvy at picking apart those arguments, you could be convinced of something, right? So this is called critical thinking. And this is why we're taking this course, so that we're able to correctly analyze information coming at us and really see if it's true or false. Now, are you going to go around in life doing truth table? No. But understanding that arguments must have a valid form, right, it's very crucial. And that will give you power when you're debating something. To be able to look for invalid arguments and say, no, 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 no. What you're saying is invalid. And that's how you do these discussions. Okay, that is it for week 3 live session. Thank you so much for watching. I hope that if you absolutely need to watch this again, you can rewatch it. That's why I recorded this. If you still have questions, please email me, or you're welcome to call at 323-834-8050. And I hope you have a wonderful week. Thank you so much. Bye-bye.